Hello, everyone. Welcome to the instructor-led workshop for NSX Advanced Load Balancer. I'm Nick Robbins, and I'll be walking you through some of our lab content today. Got a quick deck. We're going to kind of talk a little bit about the product, talk about how we built this lab, and some of the things that are in the lab. So let's get started. This agenda just talked about this. All right. So the two people responsible for this content, unfortunately, are myself, Nick Robbins. I'm a technical product manager in the NSX Advanced Load Balancer group, and Sean Watson, who's a solution architect in our professional services team. We have to come up with what's in this lab, kind of keep it fresh, do all the updates, build the pod, and basically are responsible for the whole life cycle of it. So any problems you see in the lab, you can blame on us. So a little bit about our product. NSX Advanced Load Balancer is formerly called Avi Networks. You probably know it as Avi Networks. So our claim to fame is we're a software-only load balancer. We can be deployed pretty much in any cloud. And we're a modern SDN-based style deployment where we have, what I mean is we have a control plane and we have a data plane. So the control plane is our Avi controller, and that thing sits in a management network somewhere and is responsible for all the management, the configuration management and the deployment of all of the data plane components, which is our service engine. So by doing the controller is responsible for the central orchestration. So you get a single endpoint. You can have load balancers deployed all over your data center in multiple clouds, and all of that information and configuration is done in one place. It's fully REST API based, so everything you do in the CLI or through the UI is all just a REST call. So you can easily replicate that with your own scripting. You can fit it into CI/CD pipelines, whatever. I think I've already mentioned we are multi-cloud, so you can use the Avi controller in any public clouds. You can use it in vSphere, you can use it in NSX, you can do bare metal. There's lots of different ways to deploy Avi. And because we have the separation of the control plane and the data plane, that enables us to do flexible upgrades where you can upgrade the controller to a certain level, but leave all of your data plane ones behind while you do more testing, kind of do canary testing on a small set of load balancers, whatever. Since we're software only, it's easy. We don't rely on the traditional active standby method of load balancing where you have monolithic appliances that sit there. You've got one running and the other one just waiting for the first one to die. We allow you to actually run active load balancing using our elastic load balancing model, where you spin up the VM. You've got the application running on a VM. You want to run it on more to kind of get either more capacity or more redundancy. That's pretty much done with the click of a button, and we'll actually show that in the lab. You can also do some of that stuff on demand, where you start seeing, you kind of watch the metrics, and once you start seeing lots and lots of load come in, you can automatically scale up those service engines. So these are all kind of things that can happen with our REST API style model and with the VM. So resiliency and high availability, we talked about active already. It's self-healing. If something happens to a service engine, the controller knows that a service engine is dead, and it will automatically try to spin another one up to replace that one. It's the cattle model. Service engines don't have names. We don't worry too much about them. We pretty much just let the system manage them. And like I said, the controller automatically provisions all those. You don't have to worry about it. We've got integration into IPAM. Say you're using AWS, we communicate with AWS to pull elastic IPs. We can integrate with Infoblocks, things like that. DNS integration is also there with Infoblocks, or internally, you can delegate a DNS zone to the load balancer, and when you create a new application, a DNS name will get created with it. Self-service RBAC, made a multi-cloud. It's all stuff you'll kind of see in the lab. So we're going to do this build out slide here. It kind of shows all the components. So like what I was talking about is the controller is the control plane. It's responsible for being the management component where the REST API endpoint is. It gathers all of the logs and performs analytics and indexing of those logs on that box, so that you don't need to do any of that on the data plane component. You don't have any load there for that. And then the data plane is responsible for all the actual packet forwarding, and that's where the elasticity comes into play. So you can have multiple of those service engines, and the application will be running through as many as you want, as many as you need it to do. You can scale that thing up to suit your load, and you can run this anywhere. So we've got you can run it bare metal if you need super high performance or you need a 40 or 100 gig NIC or something. Bare metal is probably where you want to go. The typical deployment is virtualized on like vSphere NSX, and then we can also do container-based deployments where you use something called our Avi Kubernetes operator to talk to your Kubernetes API server, so that when you deploy an ingress or a type load balancer, that stuff will get automatically created inside of Avi as a virtual service, which is pretty handy. And also public cloud, so you can deploy us in AWS, Azure, in GCP. And it'd be the same management and analytics experience that you'd have on-prem. You can actually use an on-prem controller to run load balancers in the cloud and on-prem, as long as you're within a certain amount of latency. But that's a good handy way of, you could do cloud bursting, you can do disaster recovery that way, things like that. So the lab, yes, constructing a lab, there's never enough time every year. I say I'm going to have this thing done well in advance of the deadlines, and I always seem to have to work weekends and nights all the way up to end to make this thing happen. This year, typically, if you've ever done a hands-on lab in the past, you know that there's a Windows-based control center that you do all of the stuff from. We were one of the early adopters to try and use the Linux-based control center. It's an Ubuntu machine where you do all of the same things that you did from the Windows box, but then you don't have to deal with Microsoft licensing on this lab environment. It also gets rid of one of my pet peeves of using PuTTY. So if you're fond of PuTTY, PuTTY's still in the lab, but I generally use the terminal for any SSH type stuff that you'd want to do. It greatly streamlined the development process for us because I could do things like SSH tunneling. I didn't have to do everything through an RDP session. Kind of enabled me to be able to do a lot of automation without having to install stuff on Windows, which is kind of nice. And this lab is based on the latest of our 20.1.x. So 20.1.6 release of the NSX Advanced Load Balancer. We are up to 21.1.1 now, but as I've learned in the past, never ever use the latest and greatest 2-week-old version in your lab because you're just asking for trouble. And we're built on vSphere 7, and we're using Kubernetes for a lot of our application deployment, our web services and stuff like that. There's a couple floating around just on Docker, but most of it's in Kubernetes. And then to build this lab, we gather ideas from professional services. We've got some education classes that they deliver, and we try to loosely mimic those. And then we get some input from the field teams too, as to what customers want to see. We do not have the Kubernetes lab done yet for this. We ran out of time, but we are planning a post VMworld update to add a Kubernetes AKO based lab, so you can see how that Avi Kubernetes operator works. Should be pretty cool. This is the architecture. It's set up in a dual site. We have multiple labs, as you'll see in a later slide. One of them is a global server load balancing lab, which is why we need the 2 sites. But you can see we've got the Linux console, we've got the VCSAs that run the vSphere clusters, and we've got the Avi controllers. And then we have 2 workers and a master node for Kubernetes in each region. And then these all sit on some virtualized ESX hosts. And then we've got a couple of service engine groups that handle all the load balancing for all of this stuff. We've got these various services running just using node ports. And then you can see the versions of the stuff we're running. So when you take the real hands-on lab, these are the modules you're going to see. We kind of go a little bit over the architecture of how our cloud connector works. And then the meat of the lab is in the application section. This is where you actually create virtual services and pools and stuff. Virtual service is probably what you would think of as a VIP. So those are the actual front-ended applications. And then service engine groups, which kind of talk a little bit about how service engine templates are built, which is where you do sizing and you can kind of get rid of noisy neighbor stuff by having different groups like that. Application scaling, which was the scale in, scale out elasticity stuff I was talking about. This is also handy for maintenance and just moving stuff around in the data center. Application services and security, which are our policies. These are a very easy way to alter the way the traffic looks. Add headers, do drops based on network security, do your HTTP to HTTPS upgrades and things like that. And then troubleshooting, we have a pretty rich set of analytics in the product, and I would be a complete failure if I didn't at least go over those a little bit. If you've used a lot of network products in the past, our analytics are quite a bit better than most of what you're used to. You don't need to do a lot of shipping off to other services like Splunk or whatever. You can do a lot of that right in the box. Also, we have a chapter that's all around migrating. We've got a toolkit where you can migrate from a lot of legacy load balancers using scripts into NSX Advanced Load Balancer. And this particular migration lab covers an F5 migration. So we kind of show you how you would get away from using that and move on to using our product instead. So we're not going to do the full lab because our lab is very, very, very long. In fact, we'll probably talk a little bit about it once we get going, how you could break our lab in pieces and do just parts of it, because you cannot sit down and do everything in our product. It's too comprehensive. So we're going to do the turbo version today. We're going to go over architecture. We'll go over the applications, like I said. And if we have time at the end, I'll do a little bit of WAF, automation, GSLB type stuff. We just kind of talk about that a little bit. And then if you're ready for more, we've got 3 different labs. We've got this lab, which is our getting started lab. We've got the O2 lab for global server load balancing, if you want to do multi-availability zone or multi-region load balancing. And then we've got a lab on web application security, which kind of goes over our WAF and different things you can do with positive security and machine learning in your application, or in the security for your application. So it's kind of a cool lab. It's based on a Jupyter notebook. So it's kind of, I guess, pseudo dev. You get to run a lot of code. You don't really need to know what you're running, but if you're into that sort of thing, it's kind of an interesting way to do it versus just typing out commands and stuff. So with that, let's switch over to the lab. Oh, I talked too long in the beginning. All right. So when you start your lab, it's going to spin up a little bit like this. You're going to get the screen. You'll see the console. It's kind of resizable in the corner. We're going to hit this maximize button like this, and we're going to get this out of the way, and you'll be able to see the whole screen. We don't necessarily need to follow the manual because we're going to do the, like I said, the turbo version. So when you first log in, log into region A, you'll log into this Avi controller. Username and password is in the manual, but it's the same as all the other HOL usernames and passwords. It's admin and then capital V, capital M, where $1. So once you get logged in, this will be the first screen you see. We've got 2 virtual services, one that must be doing something sort of DNSE and one that does our demo virtual service. So this is the default to come into applications. We're going to talk a little bit about infrastructure first. So when we talk about being a multi-cloud load balancer, we have this concept of something called the cloud connector. And the cloud connector is what enables a lot of the magic in Avi. So when we talk about automatically spinning up the service engines and stuff, that kind of requires us to have some level of interaction with the environment you're running on. So for this lab, we're going to be running on vCenter, obviously. But what this does is when you create a new cloud, so we can create this list of different clouds here. And when you set that up, it's going to ask you a bunch of questions about your environment. So let's go in here and look at it. So it's going to ask us, how do you log into it? Where's your vCenter at? What level of permission do you need? And what is your IPAM DNS? So what this is going to do is this is going to connect to your vCenter, and it's going to start pulling all kinds of information down about the environment. You're going to need a data center to tell it where to deploy objects. You're going to want to tell it how you do some of the addressing. And then the other thing it's going to do is it's going to pull all the port groups. So you're going to be able to, this all gets pulled from vCenter, and you get to pick which port group you want your management network for all of your devices to be. And then once you do that, now it knows where it can start putting data plane components. So what it does is we have all of the permissions in vCenter to be able to connect. We'll connect to the ESX host. We'll automatically push a service engine image out to that machine when we're ready to start doing some load balancing. So one won't get deployed right away. One will only get deployed once you have an application set up. So we already have a couple applications set up. So it means it's already pushed out a couple service engines. See, we've got 2 here because we want to have a buffer SE to handle in case something happens for this one. And our virtual services both sit on this one here. So these, like I said, these got deployed automatically. Once we created this virtual service, the Avi controller talked to vSphere and said, hey, I need to deploy this virtual machine OVA, which was the service engine, with these different parameters. And then the service engine comes online and tries to connect back to the controller. It sets up a secure tunnel, and they exchange all kinds of information about configuration and all that stuff. And that's kind of how the logs get shipped back and forth between the two. And at that point, you have a functioning application. So that's the cloud connector really is where all of the fun stuff happens. If we have the option to run something called a no access cloud, where you don't have to give management access to your vCenter or to AWS or anything like that. but it's a very manual deployment. You have to manually deploy the service engine. You have to do all kinds of manual connecting and stuff that you wouldn't need to do. When we do this with what we call write accesses, which is where you give access to the vSphere cloud, that allows us to actually plumb NICs. We can attach the NIC to the network where the VMs live. We can attach the front end NIC to where your VIP network lives. We can do all that stuff for you. You don't need to have a lot of that stuff pre-built. You don't need to have automation do that. We do it for you. That's why the cloud connector is so valuable, and the write access cloud is so handy. So the service engine group, I briefly mentioned it earlier, was it's the template for how these service engines get built. And there's quite a bit of different things you can do in here. The first thing we do is you can define your high availability mode. So if you need to run active standby, because there are certain services that don't work well with active. Some of the more legacy protocols like FTP, we would do through active standby. So you can set your service engine group up that way, and then you end up with 2 service engines, an active and a standby. That basically looks like everything used to look. Our default setup is N+M, which just means you have your active number of service engines that you need to run your applications plus 1 or however many, this is configurable amount of buffer space. So we typically run N+M. You can also run active. Active is very similar to N+M, except for it just mandates that every virtual service needs to be balanced across at least 2 service engines. With N+M, you can run it like we showed earlier, where your virtual service is only on 1 service engine. Obviously, there's no high availability there. There would be some downtime if that service engine died while a new one was spun up and the application was moved over to it. Most of that would be automated for you though. So yes, you would have downtime, but you wouldn't need to do a lot of active activities to bring that thing back up. Obviously in production, you wouldn't run that way. That's more for lab environments or low criticality services. And then, this is also where you configure stuff where you've got your memory and your CPU. If we were doing an AWS cloud connector or something like that, it would be a flavor of the virtual machine that you'd want to deploy. Normally, you would set these up to have CPU memory reserved. We can't do that in this lab because we're extremely oversubscribed. So we got to make sure that we allow all the VMs to step on each other. Otherwise, this lab does not even turn on. It's a very big lab. Advanced stuff, but this is where you configure the buffer. Scale per virtual service. Like I said, this is how many service engines a virtual service needs to be placed on by default. Log collection settings. So again, this is just the template for the service engines that get spun up in this group. You can have multiple of these groups. If you've got high performance apps, you can give it more memory and CPU, and then you've got your dev apps, and you can do those with lower memory and CPU, and all that stuff will just kind of get built out as needed. And then networks was another one of the things we pulled when we interrogate vCenter. You get discovered subnets. We look at the VMs that are on that vCenter, and we determine what networks all of those VMs sit in, and then that's how these discovered subnets happen, by looking at the IP addresses of VMs that are in vCenter. We can assume that network is on that port group. It's like a port group to network mapping. And then static IP pools. So we do IP pools for the data NICs and IP pools for the interface or the virtual services, the VIPs, if you will. And those can either come out of the same pool, or you can do separate pools, but you manually create those. And then you can say, do I want to use the same one for SEs, or is this for VIPs, or is this for service engines? That way you can kind of break up your networks if you need to do firewall rules or whatever, where you can say that the service engines can get out. You can allow that subnet, and then don't let any outbound communication from the VIP. That should be happening anyway. Things like that. So, all right, then we got networks, routing. You can do BGP, static routing. They'll be configured in there. We have the concept of VRFs. VRFs are an on-box thing. That VRF doesn't get extended to other networks. It's basically just a Linux network namespace splitting inside the product. So if you need to accommodate traffic separation or something like that, that's how you do that. A little quick chat about tenancy. We do support multiple tenants. You start off with one, obviously, the admin tenant. If you wanted to be able to give your developers self-service access, you create different tenants and then use RBAC to lock them down to a single tenant. These tenants are pretty much administrative domain type tenants. So it's more about organizing the components into administrative domains for users to be able to use and not step on each other's. Some stuff happens in admin where you can share. We've got different tenancy models where you can use service engines that'll be out, basically shared service engines in the admin tenant. You can share those out to the user tenants. Otherwise, if you have a tenant that wants their own service engines, you can contain them. You can contain them all into their own one little bubble. They don't need to use any shared services or anything like that. Also, you can do like template sharing out of admin, do certificate sharing out of admin. Say if you have a wildcard certificate, you could share it out to all your developers without giving them access to it. And then they would be able to deploy their apps with a good cert on it. So that was a bit about the infrastructure. Just a quick overview about IPAM and DNS again. So we've got a DNS and IPAM set up. That basically just means that we're going to we're telling the cloud connector that we want to hand out virtual service IPs from this network. So that they'll come out of that VIP static IP range that we showed a little bit earlier. And this basically just telling cloud connector that's the one we want to use by default. And we'll show a little bit more about that when we create a virtual service. And then DNS, we're set up to resolve DNS entries for region01a.corp.local. So for this lab, we're actually running bind on the Linux Control Center for corp.local, and then we delegate region01a corp.local to this load balancer. So that DNS VS you saw in the beginning, that's actually responding to these DNS queries. So we can respond to either one of these domains, region01a.corp.local or app.region01a.corp.local. And then when you create a new virtual service, you can basically create a DNS name at the exact same time. So we'll show that. But that's what that's what IPAM and DNS profiles handle. That's how you bind these different DNS domains and IP subnet ranges to your cloud connector so that when you deploy a new application in that cloud, it already knows what DNS and IP address stuff it's supposed to use. All right, so that was quite a bit in a short amount of time about infrastructure. So we're going to go over and talk about applications now. So this is kind of the meat of the lab. This applications are the VIP in front of the service. This is going to be the front end for your app. All the traffic will be funneled through here. So you can see we've got a couple of demo ones. This is just a demo VS that we've got some fake traffic going to, and it's gathering logs. Let's change this to a shorter amount of time. There we go. I made it worse. All right. So we're getting logs. We're seeing all the traffic going in and out. Right now, we've got significant versus non-significant logs. Significant logs are things that are not 200s and 300s, or anything that takes a longer than a configurable parameter for as far as response time. So things are broken. Right now, we've only got it showing significant logs, and all we're seeing is a ton of 404 errors. So when we were talking about those analytics before, this is the kind of stuff you see out of the box. We didn't have to do anything to set up to see these significant logs. This all happens all out of the box, and you can see client came in, client location from India, running a Windows box, running a IE browser using TLS 1.3, came in and tried to access this one file, and oh, it wasn't there. So we got a 404 from the app, we got a 404 from the server, and passed that all the way back down to the client. You can see request IDs, you can see the flow it took all the way there. We can get the headers, a lot of information in here, a lot of information in here. And a lot of times you needed to do stuff like packet captures to see some of this stuff in the old days. So this is quite a bit more handy than that. If you're doing active troubleshooting, you can also turn on non-significant logs. You don't usually do this in production because you don't care about the good stuff, but for demo purposes, we can see, yes, okay, here, this server does have the logo. You did not get the 404, you came from Canada. So the image must be in Canada and not in India. User agent, URI, all the same stuff, but this one had no significance. So before, when we looked in here, you can see reasons for why it got flagged as a significant log. Scroll down, significance, request ended, abnormally responsible for 4xx. So like I said, pretty handy stuff. So that's a little bit about the one that's running. I kind of got sidetracked by showing you analytics, but that's the flashy part of the demo. So it's always good to show that right out of the gate, keep you interested. Now we're actually going to jump in and create virtual services. So we've got a couple different wizards, one that's the basic and the advanced. The basic goes through kind of a few wizards all in one, but takes out a lot of the options. So we'll just quick show that. In the lab, you'll do a basic and then an advanced. So what we've got here is, okay, we're going to do our test basic service. Well, we're going to do a DNS compliant name, basic service. Okay, so auto allocate. This is where I was talking about. It's going to use one of those network ranges we already determined. If you wanted to, you could give it static IP, but you do not need to do that here. We're going to just say pull it out of this range and use this subnet. You can obviously have multiple subnets per port group, which is why we have an extra dropdown for that. And then we're going to automatically create that domain name in this DNS zone right there. Add servers. So we've got this button over here when you're doing a RAD access cloud like this, and we're actually talking to vCenter. We've got the entire inventory of VMs on that thing. So you can do select servers by network, and we have to scroll up because we have small resolution in this thing. We've got our VMs here. We click, we see all the port groups around vSphere. We know our VMs are in this port group. We're going to click it and boom, here's all the VMs. So now we know, we happen to know that this app is running on our K8S master. We're going to click add server. It's running on port 80. Got our domain name, added our server, shows up, hit save. Wait for the NIC to get plumbed. This usually just takes a few seconds. And boom, we have our virtual service up and running. It's called our basic virtual service. We've got this little pop-up menu over here. It says how long it's been up. It says it's listening on port 80. It's been assigned to this service engine group. It has this domain name. It has these various properties, which were all things that could be configured if you'd have done the advanced one, but you do not get to see any of this in the basic one. And now we should be able to go to basic service.VMware like that. How easy was that? How quick was that? That was wonderful. And we didn't need to know hardly anything about our infrastructure to do that. Just a couple of drop downs and we were on our way. So cool stuff. We should have already been logging that stuff. We'll have to turn on non-significant logs because that was obviously okay right out of the gate. So you can see these are all the different web calls we made just to bring up that one web page because it's a very chatty web page. Everything looks good. We use Mozilla on Linux. Yes, we did. Basically, everything looks pretty normal there. So now we didn't get to talk about hardly anything when we did that. So one thing I didn't talk about in basic are these, and these are not exactly all the options you get, but these are application types. These roughly correspond to what we call an application profile. So when we talk about a layer 4 versus a layer 7 virtual service, layer 4 virtual service doesn't really do any introspection into what's happening. We don't decode any of the HTTP. It's just a kind of a proxy storm forward TCP level connection. It's all very low level. That's this layer 4 and layer 4 SSL where you want to do like a secure layer 4, like if you were load balancing secure SMTP or something like that. Layer 7 is where you get all of that information about HTTP headers and all of the information about URI and all that very detailed layer 7 information. And that would be application types of HTTP and HTTPS. And like I said, these roughly map application profiles, which we'll talk about when we do an advanced virtual service. But that's what this box means. And you can see the default port is changing. It doesn't have to be 80 or 443. You can do services other than web. Like I said, you can do SMTP or LDAP or whatever, right? So lots of different things you can do on layer 4 where you don't need to decode packets and see what's happening inside there. All right. We're going to discard changes. Our first app is up. That's great. Now let's do an advanced one. And now you will see we have way more things to click. So now let's do add app. Traffic enabled just means whether or not we will respond to ARP requests for this virtual service IP. Say you're doing a migration, you want to use the same IP as your old one, you can move it over, build it, have it on, but have traffic enabled off. And then you could write a little script that would go into your old load balancer, turn it off, and then go in here and flag this traffic on, and boom, it would be flipped over. You'd have very minimal downtime in the range of seconds. It should be very easy to do. That's kind of what this box is for. All right, so you see a lot of this stuff is the same as like this stuff here is very similar to the other one. We've got okay, we've still got our port group that we pick and our subnet. So we'll do all of the same stuff. It's still going to do a domain name. And then we've got this ID of service port. So this is where we do the listening. This is our listener. So right now we're listening on regular old port 80. Let's do we want to do some security on this. So we're going to add port 443. We're going to say it needs to be SSL. And when we do that, this is hard to see in this low resolution. Let me see if I can zoom this out a bit. Not that far. Okay, so when we do SSL, it adds all these SSL settings here. So SSL profiles, this would be ciphers and stuff. So this is where you do your, let's click over there and look real quick. So your versions of TLS that you allow, which ciphers you are going to allow the client to connect with. We don't really allow, we allow, but we will throw errors on any ciphers that are not high security. Any of the CVC ciphers are older RSA ciphers, any old TLS version ciphers are all turned off by default because they're bad security. So we don't want to allow you to have holes coming into these things. We don't want to do it for you anyway. We want to let you make that decision yourself. So we keep all of those turned off out of the box. You can easily turn them back on if you need to, and that's all done in the SSL profile. And then certificate. We do not want to use the default certificate because we have a wildcard certificate for our lab already. So we're going to add that hands-on lab app cert. We support RSA certificates and EC certificates. We get much better performance with EC certificates than we do with RSA certificates because we just use the AES instructions inside the CPU for SSL offload. We don't have an ASIC to do RSA or any sort of add-on cards or anything like that since we're a software product. So that is why we get better performance on EC. Should be using EC these days anyway. It's better encryption. So now that we've talked all about security, we can go back up here and talk about these other things that I kind of blew past. So TCP UDP profile, this is network centric stuff. We do auto learn for proxy settings by default, but that's where you start getting your windowing stuff, retransmissions, NTU, all of these things that normally we would do auto learn. And we actually adjust to be able to tell how the client server connection is doing, and we can tweak it based on that. Most people would just use auto learn unless they've got some sort of very specific network setting they need to deal with. And if fast path is no proxy, we basically just rewrite the header and send it through, and then UDP. So basically, this is all of your very low level network stuff that you would only need to change if you had this very specific setup in your environment. And then, like I was talking about in the other one with application type, that really kind of corresponds to application profile. And there's a ton of stuff to set up in these. System HTTP, system SSL, or system secure HTTP, system HTTP would be the layer 7 ones, and then L4 application and SL application would be the layer 4 ones. And then DNS is a special one. If you actually want this thing to be your DNS server, you would select system DNS, and then it does all kinds of extra stuff on the background to enable storing those records, creating those records, and things like that. Again, that's not for necessarily for load balancing DNS. That's for being a DNS server. But you can set upstream DNS servers in there as well. So we're going to do a system secure HTTP, and let's go talk about what secure means versus insecure. So they're going to look the same. It's just the defaults are different for these. When we come in here, this is your layer 4 settings as far as what kind of headers you're going to see, whether or not you'll respond to upgrade requests, if we're going to add export or for multiplexing, things like that. That's HTTP, system HTTP versus system secure HTTP. If you do secure, all of these things get turned on. These would be turned off normally in regular system HTTP. The big one is HTTP to HTTPS redirect. So if you used other products, sometimes when you want to do an HTTP to HTTPS redirect, it is not as easy as a checkbox like it is here. You would have to create 2 virtual services that share the same IP, 2 listeners, 180, 1443. You don't need to do that here. You can have the same virtual service listen on both ports, turn on this checkbox, and it will automatically get upgraded to HTTPS. Because I guess we like to give you options. There's at least 3 different ways I can think of off the top of my head to enable this redirect inside of Avi, and none of them require scripting or multiple listeners or multiple virtual services. So this is just the easiest one. Export for proto in case you've got a backend application that needs to know whether or not it was upgraded. That's kind of how that happens. Strict transport security. Some of these can obviously be difficult to work with. Sometimes when I've had problems where when I want to use HSTS and I'm using Grafana behind it, Grafana gets all wonky. It probably has more to do with the fact that I don't understand what I'm doing when I'm trying to set up Grafana security. But anyway, that's that cross origin type stuff. That's all gets controlled by this thing. We can do client SSL certificate validation if you want to do mutual auth, compression, caching, and then let's actually turn these on so you can see. So yeah, we can add cache headers, be able to cache parts of your application, turn on compression. Auto is where it compresses based on the different compressibility levels. We also, if you're below a certain amount of latency, we won't compress because there's no point. If it's basically like if you're under a millisecond or under 5 milliseconds, we won't compress. I can't remember the exact number. And then DDoS, these are kind of the same defaults to prevent a lot of the common attacks. We've got a web page that goes over all of the attacks we block and can block by adjusting these settings. These are very network level settings. So we can kind of filter out a lot of this stuff before it gets too processed and causes too much of an impact on the system. Different rate limiting is based on URLs, lots of things we can do in these DDoS settings. We kind of briefly cover DDoS in our -03 WAF lab, but we won't do that here today. All right, so system secure, we're going to discard those. We're going to use the default profile WAF policy. If you want to enable a WAF policy, you can just turn that on right here. ICAP, this is a relatively new feature where we allow connecting up to last line or OpSWAT to do virus scanning on downloads or uploads or whatever. So you can basically shunt requests off to your ICAP server. Your ICAP server looks at it and gives a yes or no answer back to the controller on whether or not it should block. So that's a pretty new feature. We've got a little internal sales demo set up where you can look at that, where you basically have known bad content and you can watch it get filtered and see response codes and stuff. Error page profile, if you want to do a custom error page. So when your application's down, normally you'll just get the big old 503 error message. If you want to do something pretty like a sorry page or whatever, you can set that up in here and we can serve that. And then every application server needs a pool. We did pool in the basic one, but it was kind of handled all in the same wizard. You can do pool sharing, obviously, which is why these other ones show up. So we're going to create a new pool, and you get your own set of options for pools. So the default server port is a default listener. You can override that if you don't need to use this one. And then we've got load balancing algorithms. So you can see we have quite a number of different algorithms you can use to load balance this traffic. Least connections is the normal default we would use. Health monitors, how to tell whether or not your servers are up. Normally we'll just do a passive health monitor, which kind of watches the client server request traffic, and we'll start, there's a little tooltip that explains the detail here. So we watch it and we'll start to kind of ratchet down the amount of requests that go to servers that are responding poorly. But normally you'd want to do an active monitor. So we'll do a system HTTP monitor. And then what is our port? I think our port on this, because I've forgotten our 23080. All right. And then, so we've got that, auto scale policies if you want to be able to do automatic scaling of the backend applications. That only works in public cloud when you've got things, or OpenStack when you've got auto scaling groups and stuff. We can tell it to add a couple more if you have high load. Analytics profiles, where you set up a lot of the information about you can log into syslog. Let's just look at it real quick. I won't need to remember the list. All of your parameters to see response times, what's the things that make it significant versus insignificant. This is where you would adjust those thresholds for timing and all that stuff. And then, like I said just a second ago, scroll way down to the bottom. If you wanted to send it to syslog, this is where you would do that. So we got a Splunk server. We want to dump all of our things over to Splunk. We use syslog format, your host name, tell the syslog server, and boom, now all these things will get streamed off box. So you can log all this in your security team server or whatever, and get it off of there. Well, we keep a copy too, but then you'll have a copy in your Splunk server, whatever tools you use outside of Avi. All right, so analysts got that, got this. Okay, now we need to add some servers to our pool. It's going to be very similar to last time, except for now we're going to pick workers and hope that I picked the right port because we've got a bunch of different services running on these things. Click add servers. Next. All right, placement. These are all advanced things. Pool timeout settings, all this stuff you almost never need to do. So we're just going to hit next again. We get our review. Here's what we're getting. Let's hit save. And then, so that was our pool. Now we're back in our virtual service window. And it's going to click us over and bring us into the policies tab. Policies are pretty powerful. We have a lot of different options on things you can do here. If you have our load balancer connected to the call home service called Pulse, you will automatically download IP reputation databases on a schedule. So you can filter based on these IP reputation databases. If you just click in here real quick and do a rule, you can match, since these are network, they're layer 3-4 rules, match on port, rep, IP, and then based on that, we can allow, deny entire subnets and then, or rate limit. So, you know, low level, low impact to the system, not a lot of processing needs to go on to make this happen. It's basically like a router ACL. And then in security, discard that, we don't want. Security is similar, but at a higher level. So now we can match on URI, HTTP versions, headers, reputation. This would be another one of those ways that you can do, oh, not method, I didn't want to do method. Another one of the ways you can do an HTTP to HTTPS redirect. I'll type HTTP, I want to redirect to HTTPS. There's one way of doing it. I don't know why we have so many ways, but you know, it's probably because it's based on Linux, and Linux gives you 85 ways to do everything. So let's just follow the trend. But yes, you can do it any way you want. We're going to discard this change request. This is where you start getting into things like content switching. So if we've got a path, say we've got something, we've got a downloads, we're going to do custom value. Downloads. So we've got our normal content servers that serve the web page. We've also got a set of servers that hold static content just for downloads, S3 bucket, whatever, right? So we're going to do begins with, and then now with an action, you can either redirect it to a separate set of services, like totally different domain, as if, like if it were an S3 bucket. Or if you've got a separate set of pool servers, say they're just set up, nothing fancy on them, no Java, none of that, it's just serving some static files, you do a content switch, and you'd have a different pool set up. So let's say our basic service is that pool. And then, okay, so anything that needs to go to /downloads is now going to go to our basic service. If you worked with load balancers in the past, you're probably familiar with content switch, but if you happen to be a router guy or something, this might be one of your first times you've seen this. You can also do local response, give a response code, upload a static HTML file, and say anytime somebody goes to this particular path, I don't know, it could be a help screen. There's all kinds of different use cases you could do for this. We can also do that too, a deprecated page, something like that. That would all be done in HTTP request. HTTP response is if you need to adjust the response that the server is sending. So usually stuff like this, you would be tweaking headers, pulling headers in and out, or cookies, stuff like that. And we can change the header, we can drop headers, rewrite them, stuff. I mean, this is all basically done in the response. So you're not affecting the traffic going to the server, you're only affecting the response from the server to the client. Data scripts are our advanced level stuff. If you need to do something that can't be handled on the policy, this would be similar to an FII rule. We do our scripting in Lua because it's a high performance scripting engine. We've got a lot of custom built functions. There's some documentation on this. We don't actually really go over data scripts too much in the lab, but it is an option if you're familiar with doing I rules. Data scripts might be the first thing you look at. something like 70% of iRules can be rewritten in policies though, so you don't need to go to the data script level unless you need to do something really advanced. We're going to skip that analytics. So when we were talking before about significant versus non-significant, normally we only do non-significant logs for 30 minutes after the creation of a VS, and then we turn that off. So here is where we could set that. We're going to do it forever, and then we're going to tell it to log all headers. This logs all of the HTTP headers, client and server side, so you can see them in those log entries. Super useful troubleshooting. Advanced. I did forget one back here on policies, access. So if you want to be able to do SAML authentication to an application, say you've got a dumb WordPress or some sort of internal website that doesn't really have a lot of advanced programming behind it, you can, and you're running something like Workspace ONE in your environment, you can set up a SAML profile, and you can actually enable Workspace ONE to authenticate that backend application, whatever random web server. That could be a homegrown intranet server from 1995 or something. You put SAML in front of it and it should work no problem. And you get modern authentication for your users without having to do some sort of massive rewrite on your app. You can also use SAML and LDAP for authenticating to the controller itself for administrative access, but that's configured differently. It still uses the same kind of SSO policy, but configured in a different spot. All right, so now that I've jumped out of order, we're gonna go back to advanced. We talked about SE groups. If you had your high performance app and your low performance app, this is how you would decide which group they land on. And then various advanced options around networking and the NATing and stuff, which we don't need to go over in this lab. So hopefully we should be able to click save. And if in that long discussion, I didn't mess up, we've got a functioning application. Our pool is up, our app is up. You can see that we're on our virtual service. We got our host name. Let's go to our host name and make sure it works. Let's just go to HTTP. Local. And boom, and you can see it redirected us to HTTPS. We're at the Hackathon site. Super cool. Got a certificate. It's a trusted cert because it used our wildcard for our company and corp.local, supercorp, something, I don't know. So super easy to set up. And if I wouldn't have been talking for 15 minutes during it, you can see that would have taken us about a minute and a half tops if you're a slow clicker. And then logs again, since we turned on view all headers, log all headers, now you can see the headers. So these are the ones that changed. This is just a diff. Added our exported headers that were part of our application profile system secure that we showed earlier, and we removed the keep alive. If we blow that up, you can see all of the ones that got passed through unchanged. This is extremely handy for troubleshooting, especially the diffing. So you can see if your load balancer mangled a header or if your response header got mangled somehow. As you can see, some of these are getting included. The headers from the server did not include the keep alive. So we pull the keep alive before it goes to the server. It only does that to the load balancer. And then before it goes from the load balancer to the client, we add it back in. And then our HSTS stuff, you know, the one that breaks microfauna all the time, is in this one. So super cool, super easy analytics. Real quick, since we're rapidly running out of time, I want to talk a little bit about migration and scaling. So we saw that we're only on one service engine now. This is not fault tolerant and is lower performance depending on how fancy your service engine is. You could do like a, I don't know, 16 core service engine or something, and one would be plenty performant, but it still would not be fault tolerant. So what we're going to do is something called a scale out. So we know we've already got one virtual service set up that's up and running and ready for us. We can choose that one, or we can just have it select automatically. And we're just going to hit this button, and it's going to tell that service engine to plumb the NIC and start listening. And then there it goes. So now we're on 2. So now we have this primary and the secondary. The primary is the one that responds to the ARP for the VIP, and then it will shunt traffic over to the other service engine as needed for processing a policy and all, basically to you roughly double your throughput by doing this. You're also fault tolerant. So if one of these dies, you've already got one up and running. The only amount of failover time you have is the amount of time it takes for gratuitous ARP to happen, and switch that over in your switch so that it knows what MAC address to send all the traffic to. So you're pretty fault tolerant now. You've got your domain name. I mean, what more could you want out of a load balancer? Easy peasy. And you can, we don't want to do it on this one because we already scale it out. So we'll go to our other apps, virtual services. Something's wrong with the service engine that our basic service is on. This AQAH is under high load. We want to balance some of that out a little bit. So what we're going to do is we're going to migrate that thing. You can tell it where to migrate to again, which you don't necessarily need to. And then, so that's a service engine from, service engine to. We don't really need to do this because we only have two. So we're going to say we want to come from this one and we want to send it to whichever one is available. We hit the button. So we're going to ZV. We were on the other one previously. And done. Moved over to the new one. So now we can go back and take down that other virtual service or that other service engine and do maintenance, or maybe we don't even need to take it down. Maybe we just needed it to be have a little bit lower load. So we balance that out a little bit until we can figure out what's going on, why that one's all of a sudden having so much higher load, whatever. Also, if you're doing upgrades, you need to have a virtual service scaled out. Otherwise, you will take a long hit on the service as it needs to be manually moved to a new service engine. It's not a, it just won't be the quick gratuitous start failover like the other one. So you want to make sure that you've got high availability services, that you have those things scaled out before you do an upgrade. So we've kind of gone over the basic content of the big chapter. There's more that we could talk about web application security and about analytics. We're kind of running out of time on this. So I highly encourage you to take the other labs. The O2 lab for global, if you've got a bunch of different regions or availability zones that you want to load balance inside of the cloud, that's kind of the lab for you. Also, the WAF lab, I highly recommend that. So you kind of see what kind of capabilities we have in our web application firewall, and kind of see how we would block DDoS attacks, manipulate requests, all kinds of things that we can detect and block with that. And that's a useful lab too. And then finally, I should mention the last chapter in this lab, which is the migration chapter. If you do have load balancers you want to get off of or move to Avi and you want to do it without recreating a bunch of stuff, you can do it with migration. Obviously, sometimes that is garbage in, garbage out. So if you've got a messy config that you want to get away from, sometimes it's easier to recreate it. But if you're under a timeline and you want to be able to get this stuff done in a reasonable amount of time, the migration toolkit can help you out. Our quick plug for a use case, VMware IT used our migration toolkit to do a lot of migration to this product, or to Advanced Load Balancer, and it worked fairly well for them. So I think that's pretty much it. Hopefully now you've gotten enough of a taste in your mouth that you want to go out and do some of these labs on your own. So go out there, do them, have fun, submit your feedback, requests, things we can do better for next year, and send them in. And I guess with that, I'll sign off. Have a good day. This was wonderful. And thank you.